The Tesla Cybertruck arrived not just as a vehicle, but as a disruption to the very idea of what a car is supposed to be. From a moment it rolled onto the stage with its sharp angles and stainless steel exoskeleton, it divided the world into believers and skeptics. Yet beyond the polarizing design lies a deeper story, one of unprecedented technological ambition, radical engineering decisions, and inevitable glitches that emerge when innovation moves faster than convention. The Cybertruck is not simply a truck with new features. It is a rolling experiment, pushing the boundaries of software-defined vehicles in ways no car before has attempted. One of the most discussed aspects of the Cybertruck is its software-centric nature. Unlike traditional vehicles where software supports hardware, the Cybertruck flips this relationship entirely. Nearly every function, from steering feel to braking response, from suspension behavior to torque distribution, is controlled by software. This creates astonishing flexibility, but also opens the door to glitches that feel more like smartphone bugs than mechanical failures. Early users reported moments where the truck's interface lagged, temporarily freezing controls or misinterpreting driver input. These issues, while often resolved through over-the-air updates, raised a critical question. What happens when a vehicle behaves like beta software at highway speeds? The glitches were not always dramatic, but they were unsettling. Some drivers experienced sudden recalibration events where the steering wheel stiffened or loosened without warning as the system adjusted to road conditions. Others reported phantom alerts, collision warnings triggered by shadows, reflections, or harmless roadside objects. These incidents highlighted a fundamental challenge of advanced AI-driven perception systems. The world is messy, unpredictable, and full of visual noise. Teaching a machine to understand intent, danger, and context in real time remains one of the hardest problems in engineering. Yet it is precisely this ambition that makes the Cybertruck revolutionary. Its neural network-based driving system processes visual data in a way no previous production car has attempted. Instead of relying on a patchwork of sensors from multiple suppliers, the Cybertruck system is vertically integrated, trained continuously on billions of miles of real-world data. This allows it to improve over time, learning edge cases that traditional vehicles would never adapt to after leaving the factory. No car before it has been designed to fundamentally change its behavior years after purchase, not through recalls or part replacements, but through pure software evolution. Another groundbreaking feature is the Cybertruck's steer-by-wire system, eliminating the physical connection between the steering wheel and the wheels themselves. This allows the truck to dynamically adjust steering ratios depending on speed, terrain, and driving mode. At low speeds, the wheel requires minimal rotation, making tight turns effortless. At high speeds, steering becomes more deliberate and stable. However, this innovation also introduced early calibration issues. Some drivers felt a brief disconnect during sudden maneuvers, a sensation unfamiliar and unsettling to those accustomed to mechanical steering systems. While engineers insist redundancy systems prevent loss of control, the psychological barrier of trusting software over steel remains significant. The Cybertruck's adaptive air suspension represents another leap forward. Capable of raising or lowering the vehicle automatically based on terrain, speed, or driver preference, it enables transitions from highway cruiser to off-road crawler seamlessly. In theory, it's flawless. In practice, early software bugs caused uneven leveling, momentary height fluctuations, or delayed responses when switching modes. These glitches did not necessarily compromise safety, but they reinforce the perception that the Cybertruck is a living system, one that occasionally stumbles as it learns. Perhaps the most controversial innovation is the Cybertruck's ultra-hard stainless steel exoskeleton. Designed for durability and structural integrity, it removes the need for traditional crumple zones in favor of distributing impact forces differently. This radical approach raised concerns about crash compatibility with other vehicles and pedestrian safety. While Tesla argues that advanced safety software compensates for these risks, critics point out that real-world data is still limited. Early reports of minor collisions revealed unexpected repair complexities, as the rigid panels resist deformation but are difficult to replace or reshape, challenging conventional body shop practices. Inside the vehicle, the Cybertruck feels less like a cabin and more like a command center. The minimalist interior is dominated by a massive touchscreen that controls nearly every function. This centralization enables features never before seen in a car, such as real-time system diagnostics accessible to the driver, customizable drive logic profiles, and predictive maintenance alerts that anticipate failures before they occur. However, this also means that when the screen glitches, the impact is immediate and total. Temporary display blackouts, though rare, left drivers without access to climate controls, navigation, or vehicle settings, underscoring the risks of extreme digital dependency. One of the Cybertruck's most futuristic features is its bidirectional power system. Unlike traditional vehicles, it can act as a mobile power station, supplying electricity to homes, tools, and even other electric vehicles. In emergency scenarios, this capability is transformative, turning the truck into critical infrastructure. No production car before it has integrated such high-capacity energy transfer as a core feature. Yet early firmware issues caused inconsistent power output regulation, forcing temporary software limits until stability was improved. These growing pains reflect the challenge of merging automotive engineering with energy grid technology. The Cybertruck also introduces advanced self-diagnostics that border on self-awareness. Sensors embedded throughout the vehicle constantly monitor stress, temperature, vibration, and electrical flow. When anomalies are detected, the system logs them, correlates them with known failure patterns, and adjusts performance to prevent damage. This proactive approach to vehicle health has never existed in traditional cars. However, it also leads to situations where the truck restricts power or speed due to perceived risk, frustrating drivers who feel the system is overly cautious or misreading conditions. Autonomous driving remains the most ambitious and controversial aspect of the Cybertruck. Its full self-driving capability, while still supervised, showcases behaviors no car previously attempted at scale. The vehicle can navigate complex environments, anticipate traffic patterns, and even negotiate with human drivers through subtle movement cues. Still, glitches persist. Sudden hesitation at intersections, awkward lane positioning, or overly aggressive braking reveal the gap between human intuition and machine logic. Each incident fuels debate over whether rapid deployment accelerates progress or compromises trust. What sets the Cybertruck apart is not the absence of flaws, but the philosophy behind them. Traditional automakers treat glitches as failures to be hidden or minimized. Tesla treats them as data points, signals feeding an iterative process of continuous improvement. This approach redefines ownership. Buying a Cybertruck is less like purchasing a finished product and more like joining an evolving ecosystem. The vehicle you drive today is not the vehicle you will drive next year or even next month. In many ways, the Cybertruck represents the collision between automotive tradition and software culture. Its glitches are not signs of incompetence, but symptoms of unprecedented ambition. Its advanced features challenge legal frameworks, consumer expectations, and engineering norms simultaneously. No car before it has attempted to merge transportation, artificial intelligence, energy distribution, and structural reinvention into a single platform. This makes it both exhilarating and unsettling. As the Cybertruck continues to evolve, its story is far from complete. Each update refines its intelligence. Each mile adds to its collective memory, and each glitch exposes new questions about the future of mobility. Is perfection achievable through iteration, or will complexity always outpace control? Is the Cybertruck a glimpse of tomorrow's transportation, or a cautionary tale about moving too fast? The answers will not come from marketing presentations or test tracks, but from real roads, real drivers, and real-world consequences. And this is only the beginning. The next phase of the Cybertruck story unfolds not in showrooms or reveal events, but quietly, through software updates pushed in the middle of the night. Owners wake up to vehicles that behave subtly differently. Steering curves refined, acceleration smooth, perception logic adjusted. No other car in history has evolved this frequently or this fundamentally after purchase. This constant evolution introduces a new psychological dynamic between driver and machine. Trust is no longer built solely on mechanical reliability, but on confidence in unseen code written by engineers hundreds of miles away. Each update promises improvement, yet each carries the possibility of introducing new glitches, reinforcing the idea that the Cybertruck is perpetually unfinished by design. One particularly controversial update involved adaptive torque logic. The Cybertruck's tri-motor and dual-motor configurations allow precise control over power delivery to each wheel, enabling traction capabilities previously reserved for military or industrial vehicles. In theory, the truck can detect micro-slips in traction and redistribute torque instantly. In practice, early versions of the algorithm occasionally overcorrected. Drivers reported unexpected surges or momentary loss of smoothness during aggressive acceleration on uneven surfaces, while data logs showed the system performing as intended, preventing wheel spin. The human perception of these corrections felt intrusive, even alarming. This highlighted a recurring theme. Technical success does not always translate to user comfort. The Cybertruck's braking system further illustrates this tension between innovation and familiarity. Unlike traditional hydraulic-heavy braking systems, the Cybertruck relies extensively on regenerative braking, blending mechanical and electric deceleration dynamically. The system can adjust braking force based on load weight, road incline, and driving style learned over time. However, early glitches caused inconsistent pedal feel, where braking response varied subtly from one drive to the next. Engineers explained that the system was recalibrating itself based on recent driving data, but for drivers, inconsistency in braking, even minor, challenged long-held expectations of predictability and control beyond driving dynamics. The Cybertruck introduces a level of environmental awareness unseen in conventional vehicles. Its external sensor suite monitors not just traffic, but weather patterns, road surface changes, and ambient conditions. In extreme heat or cold, the vehicle adjusts battery conditioning, suspension stiffness, and even cabin materials behavior automatically. Yet this intelligence occasionally misfires. There were reports of the truck entering protective thermal modes, prematurely limiting performance in conditions drivers felt were manageable. These moments sparked debates over autonomy versus authority. Should a vehicle have the final say in how it's driven? The stainless steel exoskeleton, while visually striking and structurally bold, also became a source of unexpected complications. Its resistance to dents and corrosion is undeniable, but its interaction with environmental factors revealed edge cases. Fingerprints, surface discoloration, and uneven oxidation patterns became common discussion points among owners. Software updates attempted to mitigate this by recommending cleaning routines and environmental warnings, a strange intersection of digital guidance and physical material care. No car before required software-driven advice on how its body should age. Repairability emerged as another unforeseen challenge. Traditional vehicles are designed with deformation in mind. Damage absorbs energy and panels are replaced or reshaped. The Cybertruck's rigid panels behave differently, transferring forces in ways unfamiliar to repair technicians. Early collision repairs took significantly longer, not due to catastrophic damage, but because standardized procedures did not exist. Tesla responded not with redesigned panels, but with digital repair manuals, AI-assisted damage assessment tools, and remote consultation systems. This again underscored the Cybertruck's philosophy: solve physical problems with digital solutions. Inside the cabin, the relationship between driver and machine continued to evolve. Voice commands grew more advanced, allowing natural language control over complex functions. Drivers could adjust suspension height, activate power outlets, or change driving modes with conversational phrasing. However, language models are imperfect. Misinterpretations led to unintended actions, suspension lowering instead of raising, or power systems activating unexpectedly. While safety interlocks prevented serious consequences, these incidents revealed the fragility of relying on probabilistic AI for deterministic control tasks. The Cybertruck's security systems pushed boundaries even further. Biometric authentication, behavioral driving profiles, and location-based access controls replaced traditional keys entirely. The vehicle could recognize its owner by gait, smartphone proximity, or even habitual driving patterns. This level of personalization had never been implemented in a mass-market vehicle. Yet, glitches in identity recognition occasionally locked out legitimate users or triggered security alerts without cause. These moments blurred the line between advanced protection and overzealous surveillance. Energy management remains one of the Cybertruck's most revolutionary contributions. Its battery pack is not just a fuel source, but a grid-aware energy asset. The truck can decide when to charge based on electricity pricing, grid demand, and renewable availability. It can even coordinate with other Tesla products to optimize household energy use. But integrating automotive energy systems with public infrastructure introduced regulatory and technical complexities. Early software versions struggled with regional grid standards, causing charging interruptions or delayed energy transfers. These issues revealed how far ahead of existing frameworks the Cybertruck truly was. As autonomous features expanded, so did scrutiny. The Cybertruck's size and weight amplified concerns about self-driving behavior, while its perception systems improved rapidly. Edge cases involving construction zones, unconventional vehicles, or erratic human behavior continued to challenge the AI. In some scenarios, the truck exhibited excessive caution, stopping abruptly or yielding unnecessarily. In others, it appeared overly confident, asserting right-of-way in ways that unsettled nearby drivers. Each incident sparked online debate, dissected frame by frame, turning everyday driving moments into public trials of artificial intelligence. What makes the Cybertruck unique is that these debates are not hypothetical. They're lived experiences unfolding in real time. Owners are not just consumers. They are participants in an ongoing experiment. Every mile driven feeds data back into a system designed to learn collectively. This crowdsourced evolution model has never been applied so aggressively in the automotive world. It accelerates progress, but also distributes risk across the user base, raising ethical questions about consent, transparency, and responsibility. Traditional automakers observe this approach with caution. Their vehicles prioritize consistency, regulatory predictability, and gradual change. The Cybertruck rejects this philosophy outright. It embraces volatility in service of long-term transformation. This divergence represents a broader cultural shift, the collision between industrial-era manufacturing and software-era iteration. In this context, glitches are not anomalies. They are expected phases in a developmental life cycle. Over time, many early issues diminished. Updates smoothed steering behavior, stabilized suspension logic, refined perception models, and improved interface reliability. Yet new features introduced new complexities. Enhanced towing intelligence, for example, allowed the Cybertruck to dynamically adjust braking and acceleration based on trailer behavior. While impressive, it also introduced occasional oscillation issues when towing unconventional loads. Each solution uncovered another layer of complexity, reinforcing the idea that technological progress is not linear, but recursive. The Cybertruck's long-term impact may extend beyond its own platform. Its successes and failures are shaping industry-wide conversations about software ownership, vehicle autonomy, and the acceptable pace of innovation. Regulators struggle to classify a vehicle that can fundamentally change its behavior overnight. Insurance models strain to assess risk in a system that evolves continuously. Consumers grapple with the idea that their car may never truly be finished. Yet despite the glitches, or perhaps because of them, the Cybertruck commands attention. It represents a future where vehicles are not static machines, but adaptive systems, where ownership involves trust in algorithms and acceptance of imperfection, where innovation is not hidden behind polished surfaces, but exposed in raw, sometimes uncomfortable form. As the years pass, the Cybertruck will either mature into a stable, refined platform or serve as a cautionary artifact of overambition. Its legacy will not be defined solely by its design or performance, but by how society adapts to the idea of cars as evolving software entities. The glitches, once criticized, may one day be remembered as the growing pains of a new paradigm. And still, the road ahead remains uncertain, filled with updates yet to be written, features yet to be imagined, and challenges yet to surface. The Cybertruck is not the end of automotive evolution. It is a beginning, loud and imperfect, forcing the world to confront what happens when machines learn faster than humans are comfortable with.